is classification accuracy. This is an actual value. That is predicted value. Then we have CA model and the CA non-bankruptcy, CA bankruptcy. For example, there are 3 non-bankrupted companies. There are 10 bankrupted companies. One classifier gas A9, B1, C4, D6. So we can find CA model, CA non-bankruptcy, CA bankruptcy. Our approach stated expected probability. This is actual value. That is predicted value. P is predicted expected probability. So we can we have P bankruptcy and P non-bankruptcy. For example, there are 10 non-bankruptcy companies and there are 10 bankruptcy companies. So one classifier does A9, B1, C4, D6. So we can find P bankruptcy and P non-bankruptcy. What is the benefit using the expected probability? We find that each classifier has its own bias from the specific prediction direction. For example, what is the prediction bias? For example, SBN like to predict a company as non-bankruptcy. In our previous example, there are 20 companies and SBN will assign a non-bankruptcy label to most of them. SBN assign a non-bankruptcy label to 13 companies and assign a bankruptcy label to only 7 companies. Therefore, P bankruptcy is 85% and P non-bankruptcy is 70%. So, SBN has a bias of the non-bankruptcy prediction. As the slide above, we know that SBN has a bias for non-bankruptcy prediction. A classifier with a high expected probability for non-bankruptcy implies that it is more credible when this classifier predicts a company as a non-bankruptcy one. By the model, calculate expected probability of both bankruptcy and non-bankruptcy prediction as 1 and 2, based on the training set of all classifiers in the ensemble model. So we have this table. Find the maximum expected probability if the situation is tight. Choose one of them randomly. Put the classifier with P-max on the top branch node of this ensemble tree. and removed all expected probability of least classifier from the pool. So remove. Step 4. From the leaf node from the branch, the decision is made if a sample is classified as bankruptcy or non-bankruptcy by leaf branch with mass mark P bankruptcy or P non-bankruptcy. Develop a subtree from the other side of the branch node. Find the mass mark expected probability of bankruptcy or non-bankruptcy prediction from its parent branch with mass mark P non-bankruptcy or P bankruptcy as 4 and 5. So remove and mass mark is BPN. So choose this. Step 6. Repeat step 3 to 5 until all classifiers are used. So we buy this ensemble tree. Experimental result. This is dataset for this research. Please see our paper for detail. Our approach. This is our approach. Our approach outperforms voting and weighting ensemble. Conclusion. In this research, we propose an expected probability based ensemble for bankruptcy prediction in order to inherit advantage and avoid disadvantage of different classifiers. Thank you for your listening.
Questions? Would this work well for predicting to sell a stock short? If I had the information on companies and I could say, oh, that one's going bankrupt, I will sell that stock short and maybe make some money. It might be worth to look at the stock market values and to see if you could have made money using the prediction at different points. But let me know first.
Yeah, sure.
Very good presentation. Thank you so much. Next